Hello everybody, and my name is Narendra Kumar and we are from Narendra Academy. And now we'll do activity 2 in our chapter 1, Heat Physics, 10th class SSC AP, Physics through Activities, Physics Made Simple. Activity 2. So this page number 2 in this wonderful textbook, which gives such lovely activities through which we get one activity, one concept, one activity, one concept. Slowly, stepwise, we go into a very deep, very wondrous understanding of physics. Okay, and here heat. Now, activity 2. Take 2 glass tumblers and fill one of them with hot water and another with cold water. Now take a laboratory thermometer. Observe the mercury level in it and note it in your book. Keep it in hot water. So the point here is, again I repeat, take 2 glass tumblers and fill one of them with hot water and another with cold water. Now take a laboratory thermometer, observe the mercury level in it and note it in your book. Keep it in hot water. Observe changes in the mercury level. Note the reading. So keep it in hot water. Observe the changes in the mercury level. Note the reading. Changes in the mercury level and note the reading. What change did you notice in the reading of the thermometer? What change did you notice in the reading of the thermometer? Which means the mercury level. Reading of the thermometer means mercury level. Did the mercury level increase or decrease when you put it in hot water? Now place the thermometer in cold water and observe changes in the mercury level. Simple. Did the level decrease or increase? So when you put it in a hot water, did it increase or decrease? When you put it in cold water, did it increase or decrease? So it is a very simple activity. We know that bodies in contact. Now what we have learnt in the last lesson, we know that bodies in contact achieve thermal equilibrium due to transfer of heat energy. When you kept the thermometer in hot water, you observe that there is a rise in mercury level. This happens because heat got transferred from the hotter body, hot water, to the colder body, mercury, in thermometer. So in the thermometer, mercury is colder and the hot water is hotter. Similarly, in the second case, you will observe that the mercury level comes down. The mercury level comes down from its initial level because of the transfer of heat from mercury hotter body to water colder body. Thus, we define heat as follows. Now we come to a definition of heat. See, because we are using the thermometer. Heat is a form of energy in transit. See, transit is a word which we use in English. Transit, I mean transit from Delhi to Agra. So, transit from here to there. Heat is a form of energy in transit that flows, that means heat flows from a body at higher temperature to a body at lower temperature. Now we have integrated the concept of heat and temperature. If a body is at a higher temperature and if another body is at a colder temperature, heat flows. That which flows, the energy flow is called heat. The energy flow is heat. We don't say that is hot. That is, degree of hotness is different, hot is different. Heat flows from the flow of energy is actually heat. It flows from a higher temperature to a lower temperature. The steadiness of the mercury column of the thermometer. See, finally it increases and becomes steady, or it decreases and becomes steady. The steadiness of the mercury column of the thermometer indicates that flow of heat between the thermometer liquid mercury and water has stopped. So, when there is a hot water and you put the mercury or the thermometer inside, the heat flows to the mercury, it rises, it stops at a point. At that point, the mercury and the water are in thermal equilibrium. That's all he is saying. The thermometer reading at thermal equilibrium gives the temperature. So the thermometer reading, it's calibrated, no? Sorry. Reading, you know the readings, you have seen a thermometer, it's reading. At thermal equilibrium gives the temperature. Thus, we got another definition of thermometer, the temperature. Thus, temperature is a measure of thermal equilibrium. If two different systems A and B are in thermal contract, are in thermal equilibrium individually with another system C, if two different systems, A is here and B is here, A is in thermal contact with C, B is in thermal equilibrium with C, A is in thermal equilibrium with C, B is in thermal equilibrium with C. Will the systems A and B be in thermal equilibrium with each other? So, if A and C are in thermal equilibrium, B and C are in thermal equilibrium, will A and B be in thermal equilibrium with each other? We know that if A is in thermal equilibrium with C, they both have the same temperature. Similarly, B and C have the same temperature. Thus, A and B will have the same temperature. But the same temperature means what? It means they are in thermal equilibrium. Yes, A and B also will be in thermal equilibrium. The SI unit of heat is joule, J, and CGS unit is calorie. So, there is a unit of heat. The amount of heat required to raise the temperature of 1 gram of water by 1 degree centigrade. We have to define something, right? So, I want to measure it. So, I can't say this much heat. How much heat? So, we have to have a unit of heat. That unit is calorie. How much is a calorie? How much heat is a 1 calorie? 1 calorie is that amount of heat which you give to 1 gram of water and raise it by 1 degree centigrade. That much heat which you give is defined as, we have decided internationally as 1 calorie. It could have also been 2 degrees, but 1 degree is convenient, right? So, 1 calorie is a convenient unit, that we have know everything has a unit. So, 1 calorie is equal to 4.186 joules. The SI unit of temperature is Kelvin K. It can also be expressed as degree Celsius, degree C. So, you call it like this, degree C. Zero degree centigrade is equal to, now there is a conversion here, see carefully, 0 degree centigrade is equal to 273 Kelvin. How would you convert degree Celsius to Kelvin? It's very simple. Temperature in Kelvin is equal to 273 plus, obviously, so 273 plus degree Celsius. Temperature in degree Celsius. So, you can temperature in degree Celsius. That is obvious. Add 273 to the value of temperature in degree Celsius to get the temperature in Kelvin. So, suppose this is 2 degree, if the degree Celsius is 2 degree Celsius, then Kelvin, in Kelvin how much is it? 273 plus 2 is equal to 275 Kelvin. It's that simple. Note, temperature measured on Kelvin scale is called absolute temperature. Okay, but one question still remains, one deep question still remains. Okay, temperature, higher temperature, lower temperature, but what is temperature? Why? What is happening inside? That it is hotter, it's flowing from this to that. What is happening deep within? That is the subject matter of the next lesson, activity 3. So, we are doing physics through activities. We are coming to activity 3. That we will do in the next lesson. My name is Narendra Kumar and we are from Narendra Academy. Thank you so much.